right, today we're going to complete the notes on 1.3. We've talked about 1.3 already. And you had a quiz today over the real number system. And part of the thing that we're going to be looking at today is you have this chart committed to your memory, and you're going to name the numbers that the subsets that a number belongs to. For instance, if we have the number -2, well, the first time we see -2 is in these integers. So -2 is an integer, and then we work our way out of the circle, and it's a rational number, and it's a real number. Okay? The number 0 is first seen as a whole number, and then it is an integer, and it's rational, and it's real. So taking this form, this real number system graph here, and putting it to good use is what we're going to do today. So we are going to name, and again, this will be a quiz question for sure, the subsets of the real number system to which a number belongs. So example, as I just did, 0. The first time we see 0 is as a whole number. And then we bring it out to an integer, and then it becomes rational, and it becomes real. So you're going to answer this with abbreviations. W meaning whole number, I meaning integer, RAT for rational, and real numbers is signified with a double bar R, like we have a double bar P in English for paragraph. This is signifying real numbers. Okay? Another example would be the number 6. Well, I got to think about this. 6 would have been one of those numbers that I was counting to. Eventually, after I got 1, 2, 3, 4, 5, I would have gone to 6. So it's been a natural number, a whole number, an integer, a rational, and a real. So I'm going to write this out as an N for natural, W for whole, I for integer, rational, and real. You always want to finish up with real number, with it being a real number. Example of 1/2. Well, as I look at the diagram, 1/2 was not one of the numbers I started with. After I learned the concept of 0, it still wasn't. I have my number line markers, my negative and my integers. First time a fraction shows up is out here as a rational number. So this is very short, and the number of subsets that it belongs to is only 2, is rational and real. So make sure you identify RAT and real. The square root of 7. Okay, well, it's definitely not any of these, but does it belong over here? No, it belongs over here. This is an imperfect square. This is going to be irrational and real. And because it's another I, we have I up here as being integer. For irrational, we're going to abbreviate it as IRR. And then we have the real number system. Any questions there on identifying the subsets to which a number belongs? Okay, good. We're now going to talk about the perfect squares. perfect squares are a number multiplied times themselves. They're your multiplication doubles. And these numbers are numbers that all need to be committed to memory and then recognized, hey, that's 1 squared. 2 squared is 4. 3 squared is 9. And again, these are nothing more than your doubles on your multiplication tables. But again, you should know these to memory. 8 squared is 64. 9 squared is 81. 10 squared is 100. Many of us know these up to 10, some of us even further. $12 may be our limit. It is for most, because when I ask what the 13 squared is, people get stuck. 13 squared is 169. $13 is often viewed as an unlucky number. So I'm going to simulate this. I-69, that's that interstate that rolls through Fishers. Depending on what time of day you get on that, that could be bad news. That could be very unlucky if you're trying to get someplace in a hurry, especially now with all the construction. So I-69, unlucky number, 169. 196 is 14 squared, and as you can see, these two numbers are just transposed. They exchange places. So if I won't know 169 and I transpose the other numbers, I see 196, I'm like, okay, the bigger number goes with 14, the smaller one, yeah, that's unlucky, that's with 13, 169. 15 squared is 225. Now there are some other perfect squares that I think are worth your time knowing, because they're going to come up. And they're not that hard if you have them explained to you. $25 squared. Well, that's 25 times 25, or 25 quarters. If I had 25 quarters, how much money do I have? Well, 4 quarters makes $1. So 4 into 25, that'll go in there 6 times. That gives me $6. And I will have used 24 of the quarters, 24 of the 25. So I have $6 for the 24 quarters and an extra 25 cents. So 25 squared is $6.25. 20 squared is the same as 2 times 2, or 4, and there are 2 zeros. 30 squared is the same as 3 times 3, or 9, and there are 2 zeros. Well, what about 40 squared? Well, because 4 squared is not a single number, it's a 2-digit number, 16, and that's okay. We've still got 2 zeros after it. And you can play this game all day long, like so. Likewise, having some number sense to you and understanding how this all fits together. Those were zeros that I was counting here. What if I have 0.9 squared? Well, 9 times 9 is 81. Everybody agrees with that. But I'm multiplying a decimal times a decimal. 1 decimal place here and another decimal place. That's 2 decimal places. So my answer has to have 2 decimal places. And it works for all these numbers that are similar. 1.1. Well, that's like 11. That's 121. 1.1 times 1.1 means there are 2 decimal places, so I'm going to have a decimal right there. If I have 0.15 squared, that's like 15 times 15. That's 225. There are 2 decimal places in the first number and 2 decimal places in the second number for a total of 4 decimal places. So that starts out here as 1, 2, 3, 4. And I put in another 0. Does that make sense to you? You understand how the decimal places and the zeros complement each other? It's the same thing. We're talking about place values. Square roots take these numbers and say, hey, what number did you multiply times itself to get that number? Like addition and subtraction, these two things undo each other. So the square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. Square root of 16 is 4. And the square root of 25 is 5. The square root of 36 is 6. The square root of 49 is 7. 64 is 8. 81 is 9. And 100 is 10. Again, from up above, square root of 121 is 11. 144 is 12. 169, I-69 is unlucky. 196 is 14. 225 is 15. Square root of 625 is 25. 400 is 20. These are forwards and backwards, the same thing as what is above. These starred examples, again, are helpful. But if I have 0.64, I know that 64 is 8 times 8, but I have 2 decimal places. I'm multiplying 2 numbers that are supposed to be exactly alike. So if I have 2 decimal places in my answer, that means I have to have 2 decimal places in the problem. So 0.8 times 0.8 accounts for those 2 decimal places. And the square root of 0.64 is 0.8, and you look incredibly intelligent when you can do that. It's a little trick, no question. But you know it, and somebody else doesn't. 5 times 5 is 25, but I have to split up these 2 decimal places among 2 numbers. So 0.5 times 0.5. Okay? Now, if I have 2.25, that's 225, that's 15. But I have to split up these 2 decimal places, so this answer here has to have one of those in it. .0004, where 4 is 2 times 2. I have 1, 2, 3, 4 decimal places that have to be split up equally among the two numbers that I'm multiplying. So that means they each have 2 decimal places. Okay? Everybody okay with that? All right, so what do I do with all this? I can approximate the value of a root. I'm taking these 2 pieces of information and I'm going to be able to approximate the value of the square root. If the square root of 10, the square root of 10 is not one of these perfect squares. It fits right in here between 3 and 4. It is super close to the perfect square root of 9, which is 3. So I'm going to approximate this, and when I approximate, remember I have to have squiggly lines. This is about 3.2. 3.1, 3.2, it's an approximation. Don't say 3.5, because it's not halfway between 4 and 5. 9 and 16. The square root of 40 fits in right here. Now the square root of 40 is 4 units away from 36. Everybody agree with that? And it's 9 units away from 49. So it's not halfway. So it's 6.5 or less. Does that make sense? So you can guess it. I think 6.3 is a pretty good guess. Square root of 23 is going to be right in here. 23 is much closer to 25 than it is to 16. It is beyond half. So this is going to be more than 4.5. I'm going to say it's really close to 25. I'm probably going to call that 4.8. It's not 24, so it's definitely not 4.9, but 4.8 is probably a good guess. Approximating the value of a root. Okay? This next thing you're going to do is be able to simplify some more of these roots. For instance, if you have the square root of 1 over 64, well, take the square root of 1 and the square root of 64, which is going to give you 1/8. Not hard. Square root of 49 over 36 is the square root of 49 over the square root of 36, which is 7 over 6. And remember, we leave this as a reduced improper fraction. What's the answer here? What is the answer here? Anyone? Yes, ma'am. 0.03. Yeah, we just went over this, didn't we? 0.03. What's this? Yes, sir. 0.005, exactly. Okay? Any ideas here? Point 3. I have 3 decimal places here. How do I divide them equally? I can't, can I? Okay? This is a trick problem. And it requires you to use your calculator because you cannot split those decimal places up equally. Does that make sense to you? See what I'm talking about? Okay. The next thing is you're going to be able to evaluate these and determine which is greater or less than. For instance, if I have 5 2/3 and the square root of 27. Well, the square root of 27 is between 25 and 36. So it's going to be 5 point something or other. Well, 2/3 is more than half, isn't it? You understand what I'm saying? It's actually 5.6 repeating. I am 2 units away from 25, and I am 9 units away from 36. I am not halfway to 5, between 5 and 6. Does that, you see what I'm talking about here? I'm not halfway. So this is going to be much smaller than 5.6. My knowledge of these square roots, and you're going to have to be able to do this without a calculator, ladies and gentlemen. 9.5 and the square root of 95. The square root of 95 is between 100 and 81. It is about 9 point something or other. It is 14 units from 81 and only 5 units from 100. It is well past halfway. You understand that? Well past halfway, on its way from 9 up to 10. So it is going to be the greater number. The square root of 53 and 7.8. The square root of 53 being between the square root of 49, which is 7, and 64, which is 8. This is 7 point something or other. 4 units here from 49 to 53, and it is 11 units from 53 to 64. Again, the square root of 53 is not even halfway there from 7 to 8. So it is the smaller number. We doing okay here? All right. One more thing to show you, and then we'll be done for the day. you're going to be asked to order the given numbers from least to greatest. The numbers are 1/2, -2, the square root of 5, -7/4, and 2.4. We're going to start out with the two negative numbers. And the most negative, the biggest number, this is -2, this is -1 3/4. The most negative number is the smallest. So that takes those two out of the picture. The square root of 5 is between the square root of 4 and the square root of 9. So these two are being compared. 1/2 is much smaller than these, either one of these, so it is the next number in the order. The square root of 5 is only 1 unit. It's very close to 4. So the square root of 5 is the next largest number, and 2.4 is the largest. You have done this before many times. I'm showing you now how it relates to the radical. Last one. -3, square root of 31, square root of 11, 5.5, and -60 over 11. Again, I'm going to concern myself with the smallest number, the negative numbers. I have -3 and -60 over 11. Well, 11 goes into 60 almost 6 times. So it is a lot more negative than the -3. So these two are out. The square root of 31 is between 25 and 36. So I'm comparing these two.
Good afternoon.
The next is the square root of 11 because it's much smaller than the square root of 31.
Grade level meeting will be held in the auditorium, in the Leonard Auditorium, during Pathways. All sophomore pathways
Right here.
along with
Please look at this. Watch here.
to attend.
6 units away, 5 units away. So this is more than 5.5. So this number is bigger than the 5.5.
Thank you. Make today a great Friday.
So 5.5 is the next biggest, and the square root of 31 at the end. On Canvas is an assignment for you. You are to do the even problems and be ready for a quiz on Monday.